Students, so today class magnetic materials. There are three types of magnetic materials: paramagnetic material, diamagnetic material, and ferromagnetic material. On what basis the magnetic materials are classified? In last class, I told magnetic permeability and magnetic susceptibility. Now, write any three differences between paramagnetic material, diamagnetic material, and ferromagnetic material. In examination, it is very important question here. Write any three differences between para or dia, or sometimes maybe dia or ferromagnetic material. Now, arrange in three columns. The first column is a paramagnetic material, second column diamagnetic material, third column ferromagnetic material. So, in paramagnetic material, the materials which are weakly attracted by the magnet, such materials are called paramagnetic materials. So, the substance, the materials which are weakly attracted by the magnetic field, they move from weaker region of the magnetic field to stronger region of the magnetic field. Now, where dia means the magnetic materials strongly repelled by the magnet, they move from stronger magnetic field to the weaker magnetic field. The materials get repelled by the magnet and the diamagnetic materials. Last one, ferromagnetic materials may be iron, cobalt, nickel. These are ferromagnetic materials. The materials which can be strongly attracted or strongly magnetized, strongly attracted by the magnet. So after second point, permeability. Permeability of a paramagnetic material slightly greater than 1. Permeability of a diamagnetic material less than 1. Now this symbol mu, the mu symbol represents permeability of magnetic materials. Permeability. So the permeability of diamagnetic materials less than 1. So here symbol indicates permeability. The permeability of ferromagnetic materials is very greater than 1, larger or greater than 1. So permeability of a ferromagnetic materials is greater than 1. This is the second point. And point 3, this symbol represents susceptibility. So last class I told that what is the magnetic susceptibility? The ratio of magnetization to the magnetic field intensity is called magnetic susceptibility. Magnetic susceptibility used to measure the ability of the specimen after getting magnetized. Now here this symbol indicates susceptibility. The susceptibility of paramagnetic materials has low and positive. Is very important point here. The susceptibility of paramagnetic substance have low and positive. Now here the susceptibility of diamagnetic materials low and negative. Low and negative. Here low and positive for para, dia means low and negative. Susceptibility of ferromagnetic materials high and positive, or large and positive. So this is the second and point 3. Second point and third point is very important for examination point, permeability and susceptibility. So after next point, the susceptibility of paramagnetic substance is inversely proportional to absolute temperature. This law is called a Curie law. This is called Curie law. So paramagnetic materials which obey Curie law. Diamagnetic materials which do not obey for Curie law, because diamagnetic materials are independent, does not depend upon the temperature. So therefore, diamagnetic materials which do not obey Curie law. And ferromagnetic substances also. The ferromagnetic substance is inversely proportional to absolute temperature. So ferromagnetic materials may be iron, cobalt, nickel. They obey Curie law. Now state and explain Curie law. Now here symbol. The symbol is the susceptibility. The susceptibility of a ferromagnetic material inversely proportional to absolute temperature. This is a statement for Curie law. Sometimes define Curie temperature. Curie temperature, the temperature at which a ferromagnetic materials becomes paramagnetic materials. When a ferromagnetic materials convert to paramagnetic materials, the temperature is called Curie temperature. So now example here, cobalt 1394 Kelvin. So after this temperature, what happened? A ferromagnetic material cobalt converted into paramagnetic material. What is the Curie temperature for cobalt? 1394 Kelvin. So iron 1043 Kelvin and nickel 631 Kelvin. This is the Curie temperature for cobalt, iron and nickel. What is the Curie temperature? The temperature at which a ferromagnetic materials becomes paramagnetic materials. Such a temperature is called Curie temperature. So what is the Curie temperature for cobalt? So already I mentioned that 1394. So 1394, after this temperature, what happened? Ferromagnetic materials converted into paramagnetic material. The Curie temperature for cobalt 1394, iron 1043 Kelvin, nickel 631 Kelvin. Define Curie temperature, the temperature at which a ferromagnetic material becomes a paramagnetic material. So that is Curie temperature. So state the Curie law and Curie temperature. The susceptibility of ferromagnetic substance materials inversely proportional to absolute temperature. So students, now magnetic hysteresis. Magnetic hysteresis means the phenomenon, the magnetic induction within the specimen behind the magnetic field intensity. Now here E is a magnetic induction, H is a magnetic field intensity. When a ferromagnetic substance is taken through a cycle of magnetization is called magnetic hysteresis loop. Magnetic hysteresis, the phenomenon, and the phenomenon behind the magnetic induction within the specimen behind the magnetic field intensity. When a ferromagnetic materials taken through a cycle of magnetization is called a magnetic hysteresis. So now here B is a magnetic induction taken along y-axis. H is a magnetic intensity or magnetic field intensity, so taken along the x-axis. So the magnetic induction against the magnetic field intensity. Now you take one specimen. The specimen is kept at a point O. At a point O, initially the magnetic field intensity H equal to 0. The magnetic induction B is also 0. So after the H value, the magnetic field intensity increase from 0 to maxima. So B is also increased. Then a specimen get magnetized. In this graph, so the path OA, it shows that the specimen get magnetized, saturated. So after the magnetic field intensity decrease, so the graph A to B, this portion of the graph, it shows that residual magnetization. In a graph, the portion A to B, this part of the specimen within the graph, it shows residual magnetization. So then the magnetic field intensity decreases from maximum to 0. Then the magnetic induction takes the path OB. So in a graph OB, this portion of the graph OB is called retentivity. What is the retentive means? The value of magnetic field, B certain value is there, but H may be 0. So define retentivity, the property of a ferromagnetic material, the magnetic induction left within the specimen induction, the property of a ferromagnetic material, the magnetic induction left within the specimen when magnetic field intensity reduced to zero, or simply say that the property of ferromagnetic material, the value B H equal to 0, that is called retentivity. So this is one more question. Define retentivity. The property of a ferromagnetic material, the magnetic induction left within the specimen when magnetic field intensity reduced to 0. This is called OB is called a retentivity. So after H decreases from 0 to minus HM, H. So okay, 0 to minus HM. Then the magnetic induction that takes the path BCD. The magnetic induction takes the path in a graph BCD. Now this portion in a graph OC is called coercivity. So OC is called this portion of the part of the graph OC represent coercivity. So the property of a ferromagnetic material, the value of H, but B equal to 0. So the property of a ferromagnetic material required for magnetic field intensity to demagnetize completely for specimen is called coercivity. So define coercivity, the value of magnetic field intensity, but B equal to 0. The property of a ferromagnetic materials which require the magnetic field intensity to demagnetize completely for the specimen in a reverse direction. So such portion of the graph OC is called coercivity. So this is a one more half cycle. So after the same process for another half cycle, the entire loop of this area is called hysteresis loop. Then a specimen is kept at a point O, H increase, B is also increased. So when a ferromagnetic substance is taken for a cycle of magnetization is called a magnetic hysteresis. What does represent the area of the hysteresis loop? What does represent? The area of the hysteresis loop represents the energy loss per unit volume of a specimen per cycle of magnetization. This is one more question. What is the significance or what does represent the area of the magnetic hysteresis loop? The area of the hysteresis loop represents the energy loss per unit volume of a specimen per cycle of magnetization. Now we have permanent magnets and electromagnets. What are permanent magnets? The material which exhibits the properties of magnetic materials for long time period is called permanent magnets. The materials which obey the properties of magnetic materials. Which property? Magnetic permeability, magnetic susceptibility. So the material which exhibit the properties of magnetic materials for a long time period is called permanent magnets. Example, cobalt, aluminum. What are the important properties of permanent magnets? One more time, which materials are required to make permanent magnets? The first property of permanent magnets, the material should have high permeability. The material should have high permeability. And point two, the material should have high retentivity. So define a retentivity, the property of a ferromagnetic material, the magnetic induction left within the specimen when the magnetic field intensity reduced to 0. This property is called retentivity. The material should have high retentivity. And point 3, the material should have high coercivity. So how they are manufactured? Permanent magnets. So So which property of materials? The material should have a high permeability. The material should have high retentivity. The material should have high porosity. The 3 points are very important in your examination point. Mention any 2 or 3 properties or characteristics of a permanent magnets and give an example. Cobalt, aluminum. And one more, electromagnets. When voltage or current passes through ferromagnetic materials, it converts to strong magnet. Or ferromagnetic materials subjected to external potential difference. Potential difference means voltage. Then ferromagnetic materials convert into strong magnet. Such materials is called electromagnets. Examples of iron. So what are the properties of electromagnets? What are the properties or characteristics of electromagnets? This is also 2 mark question. Mention the important properties or characteristics of electromagnets. The first property, the material should have high permeability. The material should have low retentivity. Low retentivity. The material should have low hysteresis loop. Low hysteresis loop. This area becomes small. Low hysteresis loop. So 3 important properties for electromagnetic materials. The first one is the material should have high permeability. The material should have low retentivity. The material should have low hysteresis loop. Low hysteresis loop. This is the loop. This is the low hysteresis loop. These are 3 important properties for electromagnets. What are the uses of electromagnets? Electromagnets are used to wear electrical bells or calling bells. The first application, electromagnets are used for calling or electrical bells. Electromagnets are used in sound, loudspeakers. So stereo system and loudspeakers. And electromagnets are used in transformer, generators. And electromagnets are used to lift heavy objects and the cranes. Various fields are used for electromagnets. The last examination 1 mark question. Mention 1 use or applications of electromagnet. Electromagnets are used in electric bell. Electromagnets are used in say loudspeaker. Electromagnets are used to transformer, generators and cranes to lift heavy objects in the upper level using cranes. Various fields are used for electromagnet.